Welcome to another lecture on engineering graphics. Today we will learn about projections of points. So let us start with the first case of a point. So let us read the statement. A point capital A is 30 mm above HP and 40 mm in front of VP. Draw projections. By projections we mean that we have to draw front view and top view of this particular point. So let us understand this case 1 through example. Now over here quadrant system is shown and observer position is also shown, and we know that observer position is such that he can see only first and fourth quadrant. So case 1 of point is related to first quadrant. So let us read the statement again. A point A is 30 mm above HP and 40 mm in front of VP. So this word above HP and this word in front of VP tells us that point is in the first quadrant, because in the first quadrant the position of the point is defined as above HP in front of VP. This we have learned in quadrants lecture. So let us place the point in the first quadrant. So name of the point is capital A. So over here he says 30 mm above HP. So it is placed at 30 mm from HP, and it is 40 mm in front of VP. So if we have to draw the front view of this point, then what will happen? The rays of sight from the eyes of the observer will strike the point, and those rays of sight will project the image of the point on vertical plane, and that image will be called as front view of the point. And we denote front view of a point with the small letter single dash. Over here in this case the name of the point is capital letter A. So over here we have denoted its front view with the small letter A with single dash at the top. Over here we have to make one very important observation. The point was given at 30 mm from HP. So distance was given from HP, but when we will draw its front view, we will find that that distance is actually visible on VP. So this is the first important uh, thing we have to note, that if in a statement we are given distance of a point from HP, that distance will be visible on VP. Now let us draw its top view. So in order to draw the top view, observer has to change his position. He will see the point from top. Now again, fundamental is same, means rays of sight from the eyes of observer will strike the point, and those rays of sight will project the image of the point on horizontal plane, and that image will be called as top view of the point. And we denote top view of a point by small letter only. So over here name of the point is capital A, so it is denoted as small a. Now over here again one important observation we have to make, that when observer looks from top, the distance which was given in the statement from VP for the point is actually visible on HP. See, this distance of the point was given from VP in the statement, but when we draw the top view of this point, then that particular distance will be visible on HP. So over here we have to conclude that if we are given a statement in which we have to draw projections of a point, and if we are given the distance of point from HP, we have to plot that distance on VP, and if we are given distance of point from VP, we have to plot that distance on HP. Okay, so let us remove the dimensions in order to understand the next procedure. Now you see we have obtained front view and the top view of the object. Front view is obtained on vertical plane and the top view of the point is obtained on horizontal plane. Now we know that this is in 3D, and of course we work on paper, so we work on 2D. And in the previous lecture on quadrants we learned that in order to convert 3D solution into 2D, we rotate HP clockwise by keeping VP stationary. So if we do this for first quadrant will open and HP will move down. So let us rotate HP clockwise and keep VP stationary. So we will get this solution. So first quadrant takes the shape of a paper, and on that paper we will draw one line, and the space above that line on the paper will be considered for VP, and space below that line on the paper will be considered for HP. And front view of the point will be drawn on vertical plane, and top view of the point will be drawn on horizontal plane, and these 2 points will be in the same line. Okay, now we will learn how to solve this problem on paper. So we have learned this case 1, and now we will see its solution. So let us understand how we can solve this case on paper. So whenever we are solving any problem on points, the very first step is we have to understand the quadrant of the problem. So we have seen that we are given distances above HP and in front of VP. So above, in front means the point is in first quadrant. So after identifying the quadrant of the problem, we have to draw that quadrant on the paper. So how we can draw? We have to sketch one line, continuous thick line, and we will label that as capital X, capital Y. So we will call that line as reference line, and we have to represent first quadrant on paper. So how we represent first quadrant on paper? We will label VP above reference line and HP below reference line. Now in third step, we will mark a point somewhere at the middle of the line, and we call that point as reference point. From this point we will start our drawing. If the name of the point is given as capital A in the problem, then this reference point will be labeled as a small letter A with naught at the bottom. Now in the fourth step, we will read the statement. So he says a point A is 30 mm above HP. So when we were discussing this case in the quadrant system, then we found that any distance given from HP is actually visible on the opposite plane, that is VP. So same method we will apply in the solution. So we are given 30 mm above HP. So we will show this distance on VP. So VP is over here. So we will place our scale on this point, that is the reference point, in vertical position, and from this reference point we will draw continuous thin line which is called as projection line of 30 millimeters, and we will make the end of that line bold to show the view of the point. And this is which view? This is obtained on vertical plane, and on vertical plane we always get front view. So this is the front view of the point, and we learned that we denote front view by small letter A single dash. So we are ready with the first answer, that is front view of the point. Now we have to draw the top view of the point. So how to draw? For that we will read the statement again. In the next part of the statement he says 40 mm in front of VP. So distance is given from VP. So we have to plot that distance on opposite plane, that is HP. So from the reference point we have to plot 40 mm length, which will be continuous thin line. We call that line as projection line on horizontal plane, that is the opposite plane. So where is that plane? Over here is that plane. So from reference point, we will align our scale with this vertical line, and from reference point we will measure 40 millimeters and we will draw a continuous thin line, and we'll make the end of this line bold to show the top view of the point, and we label top view of the point with small letter only. So name of the point over here is A, so we are labeling it as small letter A. Now we are ready with front view and top view of this point. Now after that we have to place dimensions. So for that what we will do, from this view we will leave 1 millimeter gap and we will draw extension line, and then we will place dimension line by keeping 10 millimeter gap between projection line and dimension line. After that we will place dimension for this particular view also. So from this view we will leave 1 millimeter gap and we will draw extension line, and we will draw dimension line. Again, gap between dimension and projection line should be 10 millimeters, and we will place dimension. So this is the final answer to the first problem, that is first case of a point.